What is matter? Matter is everywhere. Everything that has ever existed and ever will exist is made up of matter. It is an everyday part of our lives, from the air that we breathe to the water we drink. All matter is made up of the same fundamental building blocks we call particles, and it's the differing arrangement of these particles and the energy encompassed within these particles that give rise to the three main states of matter: solids, liquids, and gases. Let's begin. Kinetic theory. Now, we have three states of matter with three very different properties. One can flow, one you can't compress, and the other, most of the time, you can't even see. So we need a theory, a scientific explanation as to how and why these states have these properties. So theory is an explanation. It explains why we are seeing these things occurring. Now, all matter is made up of particles. Now, these particles have a certain amount of energy associated with them in the form of kinetic energy. Now, in some cases, the kinetic energy is large, and in some cases, not so large. So the energy in this instance, as what we are referring to, is kinetic energy. So the kinetic energy, which is also equivalent to movement energy. Now, so if we put energy into a particle, the arrow will increase. There will be more kinetic energy. More energy put in is converted into more kinetic energy. The same can be said with the removal of energy. If we remove energy, the arrow will become less kinetic energy. So, how is energy transferred to the particle? Now, there are other types of energy, but the main one we'll be focusing on today is heat energy. That's heat energy. So heat energy can be transferred to the particle, which is converted to kinetic energy of the particle. And then the same can occur if we remove heat energy from the particle. The kinetic energy will reduce, it will become less. So with increased heat, we can say that the kinetic energy increases, and with less heat or removal of heat, we can say that the kinetic energy decreases. We lose kinetic energy. The particles are less able to move around. And it's this idea of particles having energy and gaining energy and losing energy, which is the whole premise of kinetic particle theory. It explains why these three states have these different properties, why some flow and some do not. So now that we understand kinetic particle theory, we can now take a look at the properties of solids, liquids, and gases, and we can explain why these three states have the certain properties they do, based on the kinetic particle theory. Let's take a look. Now that we know a little bit about kinetic particle theory, we can now apply this theory to the solids, liquids, and gases and explain why they have the properties they do. Let's take a look at solid. In a solid, the particles are arranged in an orderly fashion. They have minimal amounts of kinetic energy within the particles, so they vibrate in a fixed position. Fixed position. So they vibrate in a fixed position. Now, as the particles are in a fixed position, there is not much room for them to move around. There's minimal space for them to move into. So we can write that they have no room. So these two traits that the particles of solid have give rise to the properties that solids have. So the fixed position of the particles means that the solid cannot flow. Solids are fixed, they do not flow, they don't just turn into a puddle, they are fixed. Cannot flow. And as there is not much room between the particles due to the low kinetic energy, the solid is not easily compressed, so it cannot be compressed. Compressed meaning to squash. So now if we take a look at the liquid, the arrangement of particles are similar in that there is not much room between each particle. However, there is sufficient kinetic energy available within the particles to allow slight movements. So they aren't just vibrating in a fixed position like the solid, they are able to move around and flow. So they can flow. The particles can flow, liquids can flow. There is also no room, as like the solid, for compression. So the properties of liquid can be explained by these two. So the fact that the particles can flow means that the liquid can flow. And the fact that there is no room for the particles to move into, or not much room, it's not easily compressed. Not easily compressed. So then if we take a look at the gas, finally the gas, particles are much different. They have plenty of room to move and a lot of kinetic energy to do so. They can freely move, and they have a lot of space to move into. Therefore, the properties of gases can be explained again by these two, as gases can expand and flow, and they are easily compressed. So you can easily compress a gas into a smaller container with not much effort. You can compress liquids and solids, but it requires a really high amount of pressure to do so. So in this instance, we'll just consider solid incompressible, liquid not easily compressed, and gases compressible. So now that we've taken a look at the properties of solid, liquids and gases and why we have those properties, now we can consider the changes of state between these three states of matter. We all know about melting and freezing, boiling and possibly condensing, but now we're going to use kinetic particle theory to describe how these things occur. We'll also briefly discuss sublimation. Let's dive in. Now, imagine we have an ice cube in the palm of our hand. Now, what do we notice happens to the ice cube if we leave it for too long? That's right, it melts. It becomes a liquid, it becomes water. So, how can we use kinetic particle theory to explain this process? What makes the ice cube go from a solid to a liquid? Well, the process is called changing of state. So if we take our solid, our liquid, and our gas. So we have a solid, liquid, and gas. If we supply heat to the solid, if we put heat energy into the solid, we know that the particles will have more kinetic energy, and will have a higher ability to move around. And thus the solid becomes a liquid. And this process is known as melting. So what happens if we were to heat up the liquid further? Well, the same thing occurs. A higher input of heat energy to the liquid creates more kinetic energy for the particles within the liquid. So the particles of the liquid move around more and spread out, resulting in a gas with enough heat. And this process is known as vaporization. Or in other words, boiling. When you boil a substance, you vaporize the substance. So if ever you are boiling a kettle or heating up water for cooking, you are converting your liquid to a gas, which is the steam you see. Now, what would happen if we were to remove heat energy from the gas? In other words, we cooled the gas down. So if we removed heat energy from the gas. Well, it's the same sort of principle as adding heat energy. If we remove the heat energy, the particles of the gas will have less kinetic energy and will therefore have less movement, so the gas will turn back to a liquid. And this process is known as condensation. So the gas is being condensed back down to a liquid. It's being compressed down back into its liquid state. The particles are closer together. So if we follow the same pattern and were to remove more heat energy from the liquid, if we were to cool the liquid down further, the particles of the liquid would have less kinetic energy, even more so, and the result would be that the liquid is transformed back into a solid. And this process is known as freezing, which we all know. If we put water in the freezer and it cools down enough, it freezes. It becomes a solid again. So the particles are now back in a fixed position, they are back in a fixed state, and they cannot move around. Now, I mentioned earlier that I'd briefly touch on the process of sublimation. So that's sublimation. Now, this process occurs only when there is a significant amount of heat energy being supplied to the solid. So we have our solid, and we supply a lot of heat energy, so a large amount of heat energy, that the kinetic energy produced by this for the particles in the solid is so significant that the change of state bypasses the liquid phase altogether and goes straight to the gaseous state. It becomes a gas. Now, this is a special case, but we do need to know about it. We need to be aware of sublimation, although it is less common. So we've looked at the effect of temperature on the particles of a solid, liquid and gas. But what happens when we change the pressure? What happens when we add or remove pressure from the system? Let's find out. When we are dealing with pressure, it is easiest if we visualize the situation as a gas. So if we picture a gas, three particles, freely moving, and a lot of space to move. Now, if we imagine these particles to be within a given container, so the particles are trapped within this container. Now, it's the act of a particle hitting the edge of the container which gives rise to the pressure. Okay, so now that we've established what pressure is, what would happen if we were to reduce the size of the container? Well, if we were to make the container smaller, the same number of particles, so we will have 6 particles, freely moving as it's still a gas. Now we will notice that more of the particles will be hitting the sides of the container. So this will lead to a higher pressure. Now, if we were to take this one step further and condense the size of the container even more, which we have here, the particles will be so close together that they don't actually have a lot of room to move around. And in this state, they are a liquid, as we've already covered. So we now have a liquid. So The effect of reducing the size of the container increases the pressure, and the effect of having an increased pressure means that the gas has now become a liquid, or you could say the kinetic energy of the particles has reduced. So from this we can say that with increased pressure we have decreased kinetic energy. So as we increase the pressure, we go from a gas to a liquid to a solid, which we'll notice is the opposite of what happens with temperature. With temperature, as we increase it, it goes from solid to liquid gas. So with pressure, as we increase the pressure, we condense the particles back down to a liquid and then a solid. And obviously, if we decrease the pressure, the reverse will happen. The kinetic energy of the particles will increase.